All right, let's do some Mathity-Math. Says here, the tiny, tiny lawn in front of a tiny home has 3 lawn gnomes on it. Okay, the lawn measures 10 feet by 10 feet. Albert the gnome is located at point A, 2, 9. Bertha the gnome is located at point B, 9, 7. And Charlie the gnome is located at C, 5, 1. Okay, we can handle this. Use the coordinate plane to sketch a Voronoi diagram for the 3 lawn gnomes. Okay, so we're just doing a sketch. And this is just a sketch, so remember when you're doing a sketch, it doesn't have to be the most perfect thing in the world. You're just trying to get an idea of what's going on. So, first things first, it said said my lawn is 10 by 10, so I'm going to mark off my lawn. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do it in red so we can really see here. So the boundary of 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so all I'm doing here is just marking off. They said my lawn is 10 by 10, so I'm just going to show my lawn. Like I say, this is a sketch trying to tell a story. All right, Albert is at A at 2, 9, so over 2 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool, that's Albert's. Bertha is at 9, 7. So 9, 1, 2, 3, 4, 5, 6, 7. Awesome. That is, Bertha. And then Charlie's at 5, 1. 1, 2, 3, 4, 5, and 1. Nice. There's Charlie. Okay, so when you're making a Voronoi diagram, it's really a game of perpendicular bisectors. And so we're going to be doing a lot of erasing here, so I'm going to use this pencil, but just to really make it clear here. So first what I want to do is find the perpendicular bisector of line segment AB, okay? And you could, I guess, hypothetically kind of give it a good look and sketch in what you think a perpendicular bisector is, because it is just a sketch. But I did want to take a second to show that there is a way to use a compass, and this is a compass, maybe not like you're used to, but you can use a compass to find a perpendicular bisector, and it's actually quite easy and kind of interesting. So I'm going to line up this compass on A, and all I'm doing, I'll go to the one that says C here. It's just an arbitrary measurement. But what you can do is you swing it around, and you make these marks. And then you go to B, and this is important. You have to make it the same size. So that's why I pointed out C. So I'm going to go right back to C, right? And that point of intersection there, right? I'll just kind of fudge that a little bit. But so you see these X's we made? If you connect these dots, you're actually going to get the perpendicular bisector. That's right there. So that's a way to find it geometrically, okay? And so now that right there is my perpendicular bisector. I'm going to go ahead and erase these little X's. And I'm actually going to erase the line segment too, because I don't want to get confused. All I really want to show right now is my perpendicular bisectors, and then I'll fill those in later nicely, but like I said. All right, so I'm going to do BC now. So this is line segment BC, and I want to find the perpendicular bisector. So again, all you have to do is make sure the distance you choose is more than halfway the line segment, so the C is clearly over halfway. And then all you do is swing it around. There's one side of your axis. Put it on the other one. Make sure it's the same size. That's why I'm using, like I said, C. Okay, and you can see those curvy X's, and so you can follow that circle line right to there. Those X's that we made, okay, that will show you the perpendicular bisector. So now, again, I'm just going to lightly trace that out. And I'm going to erase those X's. And I'll come back and fix my perpendicular bisectors. So I can just retrace those. So now I got 2 of my perpendicular bisectors working. For number 3, same idea. I'm going to do, for AC, same idea. Just put it on a point. Choose a point that's more than halfway. And like I could actually choose a point way out here if I wanted. I don't necessarily want to do that, but you could. For this one, just to give me some distance, I'm going to do L. Okay, so it comes this way and this way. Then I go up to C. Excuse me, up to A. I was on C. Same idea. I said I was going to be on L. There you go. And that circle came that way. All right. So again, you can see these X's right here. If you trace those lines, voila, there's your third bisector. Okay, and I'm just going to erase these X's to make it beautiful. Beautiful might be a bit generous, but there you go. But that's it. And so these three perpendicular bisectors, they actually intersect very nicely, which will happen if you do a good job. And let's see here. We can now make, we call the cells of our Voronoi diagram. These are the cells of it right there. And there you go. You can see here, this is cell A, right? This is cell C, this is cell B. And that is a good looking sketch. Now, let's keep on going. It says here, in a dramatic plot twist, okay, like this, a gnome-eating ladybug lands on the lawn at point 4-5. Okay, the gnome-eating ladybug will most assuredly eat the gnome that she is closest to. Which gnome is about to get eaten? Oh, okay, cool. So this kind of taps into like your knowledge of how these diagrams work. And so the idea is this. So right now, each site is the location of a gnome. And if you are inside of a cell, the closest site will always be the one of the cell you're in. That's kind of the power of these diagrams. So if this ladybug lands at point 4-5, 1, 2, 3, 4, 1, 2, 3, 4, 5, you can see while she's close to the other cells, she's still clearly inside of cell C. So that means, which gnome is about to get eaten? Well, sorry, Charlie. Charlie will be eaten. Oh, I'm sorry, buddy. But that's why, because if the closest site is always within the cell. So it looks close, and it actually is close, but C is closest. Okay, let's keep going. Oh, plot twist, another plot twist. It says the ladybug flew away and all the gnomes are fine. Whew, thank goodness. To celebrate, we are adding a new gnome to the lawn. And this gnome should be placed as far away from the other three gnomes as possible. What coordinates will Drake, the gnome, be placed at? Okay, so this is kind of a conceptual idea here. And the idea is that the farthest away from these other points would actually be the intersection of these perpendicular bisectors, okay? So to find these points, we can do that. We just need to calculate the point of intersection. And to this, we actually only need two of these equations. So that's what we'll do. We'll just find this equation, and we'll find this equation, and we'll find out what that point is. Real quick, kind of like head nod check or sanity check. You know this point, the x value should be a little bit more than 4, and the y value is a little bit more than 5. We can see that from our sketch. So that helps us know if we're on the right track when we're all said and done. Okay, so I'm going to do AC. So I need to find the perpendicular bisector equation of AC. So I'm just going to, let me scoot this up so we can see it. I'm just going to do that right here. I'm going to write AC. Okay, and I know point A, this was given to me, is 2, 9. And I know point C, this is given to me, is 5, 1. All right, so first I got to find the slope of AC. To find the slope of AC, I just take the change in y. Well, how does 9 become 1? Well, that's minus 8. And how does 2 become 5? That tells me the change in x, which is 3. The opposite reciprocal will be the slope of this perpendicular bisector right here. So the opposite reciprocal of negative 8 over 3 is actually 3 over 8. So because we're going to be doing a lot of calculations, I'm just going to go ahead and convert this to a decimal. 3 divided by 8, I know it's a nice one, 0.375, okay? So my equation, so far I have y is 0.375 x plus b, Okay, so now we're cooking. So now I want to isolate this b, so I got to plug in an x and a y. Now this is where you want to be careful. The common mistake we often see here is that we try to plug in a or c. But if you think about it, this perpendicular bisector does not touch a or c, right? All we know is it touches the midpoint of a and c. So that's what we want to do. We want to find the midpoint of a and c, and that's what we're going to plug in. So if we started with the y, the midpoint of the y's, well, what's 9 plus 1 is 10. 10 divided by 2 is 5. So we know the midpoint is 5, right? 0.375. And okay, let's find the midpoint of the x's. Well, 2 plus 5 is 2 plus 5 is 7, and 7 divided by 2 is 3.5. Okay? So we have the slope times the midpoint plus b. Let me real quick, let me just come up here and write a quick sidebar. So if I do that a little too fast. When we try to find midpoint, when we try to find the midpoint of something, you just take the x values, add together and divide them by 2, and the y values, add them together and divide by 2. And that's what you'll get, okay? All right, so now at this point, it's just time to use our calculator and get some math going here. So first we'll start here, 0.375 times 3.5. Okay, that gives us 1.3125. And we're going to subtract all that from both sides. So we'll just do 5 minus answer. That's some fast work there. So we should get 3.6875. So we know our b value is 3.6875. So my first equation I can work with, I can just plug that value right back in there, is y is 3.75x. Oops. Can I make that into a 7? Okay. 3.75x plus 3.6875. So that's the equation of this perpendicular bisector. Okay, good. And I think the next one, let's go ahead and do AB. Let's do that one. So now we're going to try and find the equation of this perpendicular bisector. Maybe I can squeeze that all in over here. I'll try to write small. Okay, so AB. Da-da-da. Okay, so point A is 2,9. That was given to us. Point B is 9,7. Also given to us. Okay, and so let's find the slope. The change in y. The change in y over the change in x. Well, how does 9 get down to 7? That's minus 2. And how does 2 get up to 9? Well, that's plus 7, right? So we know that our slope of AB is negative 2,7. And so the slope of our perpendicular bisector would be the opposite reciprocal. So it would just be 7 over 2. And 7 divided by 2 is 3.5. So we know that the equation of this perpendicular bisector is y equals 3.5x plus b. Okay, so we need to isolate b by plugging in a y and an x. And this is where we avoid that common mistake. We don't plug in a, we don't plug in b, because that's not on our line. We do know that it would be the bisector, so we can find the midpoint of AB and plug in the midpoint of AB. So going to the y's, well, what is 9 plus 7? 9 plus 7 is 16, and 16 divided by 2 is 8. Okay? And let's do x. 9 plus 2 is 11, and 11 divided by 2 is 5.5. Now let's just take out our calculator. Here we go. Oops. So we do 3.5 times 5.5 gets 19.25. And then we can just subtract that from both sides. So 8 minus 19, what did I say? Oh, 0.25, excuse me. We get negative 11.25. So we plug that in. We know the slope of our next line is y equals 3.5x minus 11.25. Okay, and let's clarify we know what that is. That is the equation of this perpendicular bisector. And so we're trying to find this point, and so this point is where these two lines cross. Ta-da! And so they are existing simultaneously. When they are existing simultaneously, they are the same thing. So if they are the same thing, we can just set them equal to each other. So this is like saying they're equal. It's like saying y is y. So y is the same as y. And that means this says, well, y is this. So I can substitute that out. I would say 0.3785x plus 3.6875. And that's equal to, here we go, 3.5x, because this is y, but it says y could also be that. So we're just substituting. There we go. So now we only have x's to deal with. Great. So step one, let's subtract 3.5 from both sides. So we have here, let's see if we can make it so we can see it. Let's see if we can scoot this down. There. All right, let's do that. Okay, so we're going to subtract 3.5 from both sides. So we take 0.375 minus 3.5. We get negative 3.125. So we have negative 3.125x. This is going to be equal to, we're going to subtract this from both sides. So we have negative 11.25. Let's subtract that with 3.6875. Okay, so now we have negative 14.9375. Okay, now we just divide that by negative 3.125, and voila, we get our x value. So we know that our answer for x is Drake is going to be at 4.78, and that makes sense because we said it'd be a little bit more than 4. I'll talk about that in a second. But we've got to find the y. To find the y, we can just plug this x value back into either one of these equations. I'll do this one because it looks a little shorter. So to find this y, we just substitute an x here. So we just say 3.5 times 4.78, right? 4.78 minus 11.25. There we go. We get 5.48. Sweet. And that makes perfect sense. Let me show you what I'm saying here. Look. Oh, wow. Hit on my button, sorry. Look. D, our answer Drake's at 4.78 and 5.48. And if you look at this, 1, 2, 3, 4, just past 4 up there, and just past 5 right there. So that checks out. That passes like our sanity check. Great job. So that's where he's at. And then the question was, well, how far is Albert? Oops, let me come so you can read that. I'm sorry. How far is Albert from Drake? All right, home stretch. All we gotta do is the distance formula, right? And the distance formula tells us all you got to do is take the square root of x1 minus x2 squared plus y1 minus y2 squared. Remember, those are just labels. You could put x2 minus x1, y2 minus y1. It really doesn't matter. You just got to plug in. So we know D, right? But we know A is 2, 9. I'm just going to get that there for reference. Okay, so let's just plug in. We'll use A first. Oh, no, we can use D first. We'll avoid the negatives. Okay, so we'll put my first A is 4.78 minus 2. That's that x value there. Squared plus 5.48 minus 9. We're going to get that negative anyway. And then we square that too, right? And at this point, this is just a great chance to just put this all into your calculator, move on with our lives, and get this problem solved. So make a little bit more space. Home stretch. I know this is a long one. Let's do it. Square root. Parentheses. 4.78 minus 2, close parentheses, squared, plus parentheses, 5.48 48 minus 9 squared. And the distance is, 4. We'll say 0.49. And this is in feet, so 4.49 feet. And there you go. Interesting enough, real quick, so we're on the same page here. If Drake is 4.49 feet from Albert, Drake is also 4.49 feet from Bertha and 4.49 feet from Charlie, because that's how these diagrams work. Boom, pow, we did it. That was a lot. Good job. As always, if you need questions, if you have questions or need clarifications, just put them in the comments below. And if you want more amazing math problems, please subscribe to Mathity-Math. Thank you.